End of Year Test 2020 for Year 1s, Newcastle College and Stafford. Question 10. The circle equation. There it is. And we've got to find the coordinates of the centre and the exact radius. So that's a nice standard question because we've got to complete the square and then we can read the coordinates of the centre and the radius. And then for 5 more marks, we've got some geometry to do, coordinate geometry and a bit of algebra probably. The line with the equation y equals k. So that's a horizontal line. Is a tangent. Okay. So that's diagram we're going to draw for that one. And the line with the equation y equals p. So that's another horizontal. So from the same diagram, we can, the same diagram probably for part B and C will help us answer parts B and C. So for part A, nice and simply, we're going to complete the square on that. So we've got x plus 3 squared. So link those together, halve this number, put it inside the bracket with x, square this number and take it away outside the bracket, plus y. So we're going to put the y squared and the y term together, half the y coefficient, put it inside the bracket with y, square the bracket, square this one and take it away. We're going to take away the 14 and that's equal to 0. So that's probably 1 mark to try and get the equation of the circle in a normal way. Remember, if we have x minus a squared plus y minus b squared equals r squared, then the centre is at AB and the radius is r. So what have we got here? Well, the centre is minus 3, 2. So minus 3, 2. And we need to put the minus 4, the minus 9 and the minus 14 together. Bang it over the other side and square root it. And we've got x plus 3 all squared plus y minus 2 all squared is equal to 14, and 4 is 18 and 9 is 27. So this is root 27, which equals 3 root 3. And that's exact. Either one of these is fine. They're both exact. If you decimalize either of those, it's not exact anymore. Leave it as a third. So we've got a centre of minus 3, 2, which if we draw our diagram to help us out to do parts B and C, minus 3 and 2 is our centre, which we could label on the diagram. Radius is 3 root 3. Or root 27. Well, from there to the origin is a distance of 2 squared and 3 squared, which is 14. So that distance is root 14. So root 27 is going to be nearly double that. So if we keep our distances, if you like, fairly relative and proportional, we've got something like this. And we've got a y equals k line, which is a tangent. Okay, so up here somewhere and down there somewhere, we have gone a distance from the y coordinate 2. We must have gone a root 27 distance there and another root 27 distance there. So y equals k. We need the coordinates of the y coordinates of these lines. So k is equal to 2 plus or minus the distance we've gone, or k is equal to 2 plus or minus 3 root 3. We're going to radius distance from the y value of 2. Not the x value, the y value. The line with the equation y equals p is a chord of C. And the length of that chord is 4. So we've got another horizontal line, either somewhere down here or somewhere up there, that this distance is 2. This distance is 2, this distance is 2, or that distance there is 2. And these are more y is equal to p. Y is equal to p, and p is negative. So we don't want that one. We want to worry about this one. And we want the value of p, so we need to know how far we've gone down from 2, from the y coordinate of 2, down to the y coordinate of this line here. And I can see that if I draw a radius there or a radius here, then I've created a right angled triangle, either one, And if I think about so this is part B and part C. If I think about my right angle triangle, I've got a distance of 2, a distance of radius, which is 3 root 3 or root 27. So let's call it root 27. And to find this value, it's equal to the square root of 27, take away 2 squared, which equals to root 23. And 23 is prime. So P will be start at the 2 and take away that distance to get to this line. So 2 take away root 23. So there's our final answers. And highlight them if you want.